To also start the live stream. Okay, no. Hi. Yeah, so I see you in the studio and okay. Hi everyone. Welcome to our September session. I'm Bhumika and I'm one of the co-organizers of PyLadies. So I'm going to give a quick introduction of PyLadies. We're a nonprofit organization. We're a nonprofit organization who believes we're a nonprofit organization who loves coding and wants to share our love for coding in every way. So we have regular workshops, boot camps, talks about a lot of things related to Python, anything related to Python under the sun, and everyone's welcome to join in these sessions and learn more about Python. And we want to encourage women to participate in these events, hence Python and ladies, so PyLadies. So welcome to our session, and I want to welcome our speaker, Dânia. She just graduated from a boot camp and she volunteered to give a session. So, a big round of applause to her. And Dania, the floor is all yours now.
Hi, thank you. Thank you, Bhumika, for having me and inviting me for this session. So, yes, as you already said, I have just finished the online bootcamp that was provided by you, the PyLadies Amsterdam, about machine learning ops. And it was amazing. Like I had the chance to learn during 6 weeks and also to work on a capstone project. And it was really good for me because I was always, I'm working as a data scientist, but always focused on the modeling side of things. And with this bootcamp, we learned how to deploy it, how to monitor it, and all the aspects that happen like after you develop the model. So it was very welcome and complementary information for me. And I thought, well, the least I can do is to give back to the community. So I will provide you now today with a workshop. Let me share my screen so you can see. Yes. So the topic that I'm going to present today is the introduction to product list sorting. So this
I
is
can see a screen.
beginners. Yeah, it's a beginner's workshop, so everyone is welcome to try it out. And this is really, if you have never done any machine learning model in Python before, we're going to use scikit-learn, and today you have the chance to try it maybe for the first time. Okay, so just before I dive into the topic, I would like to say a few words about myself. I am head of data lift and founding member at the AI Guild. As I mentioned, I have a career in data since 2012, and my focus has been working with machine learning models for predictive analytics, mainly with applications in marketing and forecasting. And I have also been a bootcamp teacher. I'm based in Berlin, so the bootcamp was also here in Berlin. You can find me on LinkedIn. I'm happy to grow the network. And if you have questions about the workshop today or anything related to the AI Guild itself, I'm happy to connect and exchange with you guys. Just also a few words about the AI Guild. It's the venture that I started. We are a community for data and business professionals advancing AI adoption. So now we are more than 1,000 members. We started in 2019 with in-person events. Now we have both in-person and online events. And we have two main focuses. One is data career. So we are supporting the development of careers for starting on entry level, but also for mid, senior level, and expert. And we have also Data Lift, which is about deploying data analytics and machine learning solutions. So I would invite you all to check the AI Guild page and to also become a member. We have some online spaces on Slack and on LinkedIn, and the membership is for free. So about today, what I planned for us is to have first a brief introduction about the product list sorting. So what this is about and what are the applications. And I will use PLS as the short name for product list sorting. Then I will show how we can use machine learning to create a PLS. There are different ways to to sort products, and today we are going to focus on using machine learning. And then before we end, we also want to measure what is the performance of this machine learning model. So I'm going to show also a way that you can measure this. Yes, let's start the introduction to PLS. So here, where this is relevant is mostly for e-commerce. So if you are a user browsing a website, how do you find what you need, right? And this is similar to experiences that you might have in physical shops. Like if you go to a shopping center or to some shop street and you are there walking, you're looking for something. So maybe you know what you're looking for, and that's the first option here. So you search for something, and you can also use the filters. In an e-commerce, you would go to the search bar, you search for what you're looking for, and you get the list that matches your result. Maybe you have an idea of what you want, and you click on the product, and then you see that part that says you might also like this other ABCD product, or maybe it shows you like people that bought this product also bought that other product. So this is a way for you to get new ideas or recommendations on what you might like. And the third one is category browsing. So maybe you are not specifically looking for something, and you also don't click on anything to get recommendations, but you go on the website and you click on the category, for example, organic cosmetics, and then you will see a bunch of products there. So this is, or those are the three ways that people can find products. And what now we are thinking is, well, if you are owning this e-commerce, you want to get the right products in front of the customers, right? That's crucial. You don't know exactly which are the right products or what people are looking to buy, but you want to get them, you want to get the potentially right ones as the best next thing you can do. So people don't have to browse a lot and maybe figure out that they don't find what they want in your shop. So the idea of product list sorting is to show what is relevant to the people that are browsing at the top of the page. And for now, we are going to really focus on this third aspect, the category browsing, because this is where it is maybe a broader way to find products. And it's a way when people are getting inspiration. So the first, compared, for example, with the first way to find what you need, here you basically know what you want, and the products that are going to show up, they need to match your search query. And for recommendations, also, you need to have some action, like maybe you buy something or you click on a product and then you get recommendations. But for categories browsing, it's the potentially the first chance that the e-commerce has to show something relevant for a user that is just browsing and looking for inspiration. Maybe, for example, I have been in this situation that I don't have kids myself, but I was looking for a present to a friend that has a kid, and I didn't really know exactly what to buy the kid. So I went there and I started browsing on categories, for example. So looking for different kinds of toys and getting inspiration on what to buy. So this is when the list that we show, or the order that we show the products, can become more relevant to engage the users and to find what they want and get a sale. And then how we can use machine learning to create such a list, right? So there are different contexts. As I mentioned, if you are dealing with search, there needs to be a match in relevance. That's why we start with the high level idea of the category. So let's say you have a shop and people click there on a specific, for example, organic products, and now they're going to see your entire catalog of organic products. So what to show on top, or how to order that list. So one approach is to use a statistical algorithm related to conversion. So if people buy or not the products. For example, you start with the site here, the input. Let's say the first 3 products you have are in a random or could be following some business logic, for example. And then you'll see how the customers will react. So you have the probability that they will buy or that they will not buy, depending in the order that you show. So based on this, you can use those actions of buying and not buying after seeing that order of products to manipulate this in a training set, and then use the training set for training a supervised machine learning algorithm. And then you have the list, which in this case would sort higher or rank first the products that have the higher chance to be bought. So the idea here is that you really use the conversion rate from what you have seen in the past, from the order, the list that you had before. And that's how you have a new input. And then again, you deploy this to your website in your e-commerce, and then you see if people are buying or not. And that way it becomes an iterative process that every time that you have a new sorting list, you can measure again how it is working and train a new model or update your model and have an updated list. Because for sure, there are new people browsing the platform every day, or there are new products every day. So this is a very, let's say, live process, a live process. Okay, then this is somehow what we have, the process that we have. But then what kind of machine learning model you can use to actually train this conversion or the prediction of a conversion? This is the part where we can play. So because this is the introduction workshop, it's the first time we are thinking about this, let's start simple. And this is also an advice that I hear and I practice this a lot. You start simple and then you iterate on your solution, making it more complex. So here on the side, we have this image about the machine learning landscape that I took from this website, like Machine Learning for Everyone in Simple Words. They explain all the concepts that you see here in the graph. And from all of those, we are going to focus on one of the simplest, which is supervised learning. And because we want to predict the conversion, which is a number, then we do a regression. And in general, how the supervised learning works, just to recap. So we have the training set. Each row is a different product from our catalog. Each product has a bunch of information like the brand, price, and we can get the conversion rate because we know how many people saw the product on our page and how many people bought the product at the end. And on the task set, we probably have a product that potentially is a new product. Again, we have the same information, in this case, the brand, the price, but we still don't know the conversion rate. And then from the training set, we derive the machine learning model. So we use that to train. And once we have the model, we can apply it to the test set and we will have a prediction for the conversion rate. Using that prediction, we will sort the products. So the one with the highest predicted conversion rate will be ranked as number 1, the first one that will show up at the page. So here, oh, sorry, let me go back again. So here the machine learning model can be various in this aspect because we're talking about supervised models and about regression as the problem, but the approach or the algorithm that can be used are different ones. And again, let's start simple. So I will have the example now with a linear regression. So maybe this again is a reminder or just a recap. But the idea is that we have a bunch of input or features from the product. So this is what we know and what we take from the catalog. And then we have the target or the label, which is the conversion rate. And the conversion rate is what we calculate based on the data from the users that are browsing the website and buying, so transactional data as well. And the way that we can model it is that we have the conversion rate being the A value, so a coefficient times the brand plus a coefficient times the price, and so on for how many other features you have about your product. Just two observations is that in this case here, I put two different examples of input variables, and they have different ways to be modeled. So the brand is a category, so it's a text, and it needs to be transformed to a numerical before we can use it here in this formula, right? We cannot just multiply a number by a letter. So we have to transform this to numerical. There are various ways on how to transform it, but the price can be directly used because it's already numerical. So the idea here is that we are going to, first of all, start with the price because it's already numerical, and use the price to predict the conversion rate. So it's quite simple, just one variable, and we can see how much of a difference it would play for the sorting order. And then as a next step, what we could do is either try different algorithms or try coding the brand from a categorical to a numerical variable, and also use that to predict the conversion. Finally, before we move forward to the hands-on part, let's measure the model performance, right? So what we want at the end is not actually to know if the model predicted the actual conversion rate. So it's not that important that potentially the model predicted a conversion rate that is higher or lower, but we want to know how on average the predictions were, because how good on average the predictions were, because we care more about the order or the sorting list of the products. So if the first product is still the first one or the highest conversion rate, then that's good enough. And one common metric that is used to measure performance for regressions is the mean absolute error. And here we have the formula, and here also a representation how it works. So we have the number of samples, which in this case would be the number of products that we have in our catalog on the task set. And those are represented here by the blue dots that we have. And those are the real values here. And then the predictions would be on this green line. So it's a linear regression. This is, let's say, the conversion that is predicted by the model. And then the mean absolute error is just the distance between each of those blue points, or the real conversion values, to the predicted conversion value. So sometimes the predicted value is going to be higher than the real one, but sometimes it's going to be lower than the predicted one. And in this case, we don't care. It's just the absolute value. So we just take the norm of the difference, we sum up for all the samples and divide by the number of samples. So now that I spoke a lot, I hope that I gave you an idea of how this works and why it's important to do this and try it out. I will move to the part where we talk about, or we show really the code or how to do it. Let's change the window. So if you go on the GitHub repository for the PyLadies Amsterdam, you should find there this introduction to product list sorting with all the code that I'm going to show you now. And if you would like, maybe we can take some minutes for you to clone the repository and see the code by yourself and try running it. Also for this, maybe it makes sense that I open on the window as well. Give me a second. Here you go. So maybe you can let me know if it's too small, or if there's a way that I can make it bigger. The idea here is that the requirements we have is to work with...
it would be nice if you zoom in a bit, maybe.
Yes.
I think Control+ usually works with VS Code, so.
Yes, like this, yeah?
Yeah, that's good. A
Yes,
little.
so
This is perfect. Yeah.
yes, so this is just the README of the repo you will find there, but the idea is that to run this code, you need Python 3.8 or higher, also Conda or mini Conda, and we are going to work with a data set from Kaggle. So you need a Kaggle API token. Here I give you a brief explanation how to get this. So first of all, you need to sign up for a Kaggle account. It's for free. And Kaggle is a place where you find a lot of resources about data science. So they have some courses, they have the challenges, which are sometimes provided by companies that have a real challenge that they publicize it. And a lot of the times they also provide prizes. So a lot of people have gotten some money because they found a good solution for the company challenge. In our case here, this is just to get the data set. But what is also interesting for Kaggle, if you are not handling well the installation aspects, and if you have a lot of trouble with the packaging or the Python versions, you can also execute code directly on Kaggle. They also have like the notebook that you can the notebook infrastructure that you can use basically on their cloud. So this is also another option that you can just execute Python code there. It's like in a notebook. Okay, but then maybe I can also show you how it works. Yeah. So when you go to Kaggle, you have your home page. Then if you click on your picture, on your profile, and you can go to your account, and in there you can see API. So to create one, you just create a new API token. I'm not going to create a new one because I have already done it. As soon as you click here, you will get a JSON file. This will be named kaggle.json. So after you have this file on your computer, you can just place it in your home folder in this hidden Kaggle folder, or on Windows, it's under your users and your name. You find again this hidden Kaggle folder to put there. About the Kaggle API, a few words. Well, in this case, we're going to use it via the Jupyter Notebook, but it's actually possible to use it via command line. So you can use command line directly to download data sets that are available, publicly available on the platform. You can also submit your solutions to challenges from the command line. And yeah, so once you have already your Kaggle API token, you can clone this repository, you go to the folder, and you can create a virtual environment. So I have created this environment YAML file with all the needed packages to run this code. And like you can see here in my window, I already have VCS open. So when you just click there on the files, yeah, you have inside the workshop folder the Python notebook, and then from here you can choose the kernel that was just created, so this PyLadies intro PLS. And this is how you know that you are executing the code in the right environment, that you have the packages installed to execute. Maybe also, if you have any questions, feel free to send them in the chat. You don't need to wait until the end. Maybe something already came up, or throughout the execution of the code, you find some curiosity that you want to send. Please do send it. I give you some minutes so you can get also the environment up and running on your computer, and maybe we can execute the code together.
Yep. So far, we have one question in the chat about the GitHub link, which I have posted in the chat. So, yeah, if I think in the meantime, during the break, any questions, feel free to drop it in the chat.
Yes, thank you, Bhumika, for sharing the link. Yes, so just a brief repetition again. What we are going to do now is train a machine learning model in Python. So we are going to use the scikit-learn library, and we're going to use a linear regression that will predict the conversion rate. And then this is what we can use. The conversion rate is what we can use to order the products and hopefully show the most relevant products at the top for the people browsing the website. So before we start, we need to get some data. This is the input data I found available in Kaggle. It provides some e-commerce events, so you can find more information on the links I left there. And this is the code that we are executing on the command line. This is why you have the exclamation mark at the beginning. So the command is Kaggle datasets download -g, and then this is the specific name of the dataset. I'm not going to download it again, but it was downloaded already. You can see some progress bar. So I will also maybe give you some minutes to download, some seconds to download it. The idea is that it will download to the same folder where you are executing the command. So it will be together with the notebook. And it's a zip file. So I added next a way to just unzip the file, and after I'm just deleting the original file. And when I unzip it, I'm saving it to this folder input data. So what I have here is input data with the data, and then the product list sorting notebook here. Also, the presentation is available if you want to check it out later. Okay, so now we can load the CSV data so that I extracted to this input data folder, and the name of the file is event CSV. And we can show a bit how the data is. So it's again, events for e-commerce. So we have the timestamp when it happened. We know what is the type of the event. In this case, it's a view on this product ID, the product category ID, maybe the category code. We have brand, price. We have a lot of information about it. There's also a user ID and user session. So this is all anonymized. And what would be interesting is to find the complementary data set, which tells us, for example, what is this product? Because here we only have the ID, so we don't actually know what the product is. We know that maybe it's some kind of phone, or here's a cooler for a computer, but we don't know what the product is. And again, checking what is the kind of information we have. So we see that, for example, the price is already a float, and the event time, if we wanted to use it, we would have to transform it to datetime because it's still an object type. But in this case, it's not that relevant when it happened. I'm trying to keep it simple and focus on the final result. So we have different types of events, and if we group by the event time and count how many different user sessions we have, this is what we can see. So most of the events are views, and then we have some purchases, and in between you have to add to cart. So the idea or the logic usually is that you view a product, you add it to cart, and then you purchase. So again, for the conversion, what we need is the view and the purchase. So we don't care about the cart. So what I'm going to do first is to just keep in the data set the view and purchase type of events. And then what we want is to have the number of orders and the views or impressions per each product ID, because then we can calculate the conversion, which is the number of purchases divided by the number of views. So I use this pivot table operation, and the product ID and the price, they are fixed. Again, I am assuming for simplicity that the price for the product does not change for the data set. And then in the columns, I want the two event types, view and purchase. And the values are going to be the count for different user sessions. And I just put a fill NA to 0 because if it happens that a product has 0 views or 0 purchases, then it would be NA since the count is non-existent. So after we execute this, this is the table, how it looks like. For each product ID, we know its price. We know that there were 5 events of purchase and 19 events of view. This is just to get flattened the column names. And now we can directly call the columns as they are here. And then a quick check. So important before we start modeling that we have an idea of what is it that we are working with. So how many products we have, the range of prices, how many purchases and views we have, like how the distribution looks like. So we can see, for example, that there are some outliers, like price. It has one product here that is sold for 60,000, 64,000 euros or dollars. I don't know the money. Seems weird. Also, some product that was bought a lot of times. Yeah, purchase somehow is low signal event because 75% of the products have 0 purchases. But view looks a little bit better. So what we want to do first is not consider the product with no view. Just because then if nobody saw the product, we are also assuming nobody put added to cart, thus nobody bought it. And we don't want to use that for training. Because it could be that nobody saw this product because either it's a new product, because it hasn't been for a long time in the platform, or because it was always the last one to show and nobody like clicked through all the pages to get there. You know? So I will remove the products with no views. And if you are looking to do a better model or to have a better training set, you should also look into those kind of outliers and see if you want to replace them, if you want to exclude them. There are many different strategies on how to handle outliers, but for now, we just keep them in the data set. And yeah, now we can see that the minimum number of views is 1. So this is how the data set looks like. And yeah, we're still missing the conversion rate. So here, the number of purchases divided by the number of views or impressions. And now we have here what is going to be the target for our model. Also interesting how many products we have in this database. So it's quite an extensive database, 53,000 products. Thus, yes, there's a lot of them that are not bought. We know that that's the long tail of retail. This is how it is. A lot of the products are not bought, and some few products are the ones that are popular and that actually sell on the platform. And yeah, as I mentioned, we do have some weird prices. So I created a histogram here so we can see how it looks like, but only for the ones that have prices below 500. Still, we can see that the majority of the products, they are here between 0 and maybe 50 money values. Well, one thing that we can also do is to check the correlation. So in this case, we can, again, only consider numeric variables to calculate correlation, otherwise it doesn't make sense. But here we are going to use the price to predict the conversion rate. And we see that the correlation is very low, but still it's a -1, which makes sense if we think about consumers also. The lower the price, the higher the chance you have to buy something, or the other way around. The higher the price, the more expensive it is, the less people buy it. So this would become more relevant if you have more variables that you could see, maybe the ones that make more sense to add, or maybe you have input variables that are correlated to one another that you could work around. Great. So now that we have a bit of the idea what to expect from this, we can split our training or our data set into training and test set. So I just set seed here, and I split 30% for testing. And now we can use the two NumPy method to transform the data from a data frame to a NumPy array, because this is what is required for the scikit-learn training and fit and predict methods. So first of all, we can also check, for example, the first row, which was up there, or real up there. Yeah. For example, this one, I think. And here is now the X and the Y. So we have the X, which is the price, and the Y, which is the conversion, or what we want to predict. And here is how we define that we're going to use a linear regression. So right at the top, I already imported the linear regression for scikit-learn. And this is what we need to use. It's usually fit, and then we use the model predict to predict the values. So again, for prediction, we need to transform it to NumPy. I didn't do that before, that's why I'm doing it here. But basically, you say which are the input variables. So in this case, only price, and it can give you the predicted conversion rate. And I'm adding this as, this is just again an NumPy array, and I'm adding it as a column to our task data frame. And this is how it looks like in the end. So we have the real conversion rate for the task set and the predicted conversion rate. And again, we can evaluate how good the model is in predicting the conversion rate. So again, on scikit-learn, you find the metrics. Under metrics, you have a bunch of different metrics that are already implemented. So we can use, for example, the mean absolute error. And then use both of them have to be a NumPy array. So here I just converted the conversion column to NumPy and used the predicted attribute, or the predicted that was here calculated before directly is NumPy array. And okay, we have here the value like 4.4%. It's really hard to say now if this is good or bad, because it's a number without the context. So what happens is that this could be, or this should be looked at and compared to different strategies of modeling. So one of the things that you could try out now for the next minutes is to use different algorithms in scikit-learn, for example, or you could also try and use more attributes. So on our data set, we do have some information about the categories and the brands. So you could try to, for example, categorize that, take that category and transform that into numerical, for example, one hot encoding or something like this, and see if you have lower mean absolute error. In that way, by looking at different maze for the task set, you can figure out which is the one that theoretically is the best one, because it's closer to the real conversion values. Still, again, this is about the product list sorting, right? So we want to see how much that changes when we show, or when people browse the website. So they're going to see, let's say, the category of organic products, and what is it that they're going to see as first product, second product, and so on. So here I am just printing the first ones by the real conversion rate. So this is what we would have. And the conversion rate 4%, 3%, 2%. So those would be the first ones. But we can already see here that the predicted conversion rate is a bit different. So in this case here, maybe the one that is on second would be first, and so on. Still, a lot of them, maybe they had, like in this case, it had one view and one purchase. So how relevant is this product for what we are trying to build? Like if one person saw it, or in one session there was only one session saw this product, if this is still relevant for modeling something that is going to show to everyone that browses that category. So this is a question that maybe you also think, well, what about things that were bought only once? Are they relevant enough to use in a model that is going to then change the product searching list for all people that go to the website? Maybe it's not relevant. So maybe you want to remove it from your data set and not use it for training or testing. So those kind of things start to become topics for discussion between us, the data people, and the stakeholders or people that are working with us also from the business side. Because it depends, right? If you have some category that is not so popular, or if you have a new website, like say the e-commerce is pretty new, then yeah, maybe one view or maybe one purchase is already a good signal. But if you have, I don't know, millions of consumers and millions of sales every day, then you should probably have some cutoff points to say, from this value on, it's relevant. Let's see. Okay, but to compare, let's take the first 5 products considering the predicted conversion rate. So when we look at the predicted conversion rate, then the products on top would be different. And here's where we can see clearly the difference between one and the other. Well, we only have product IDs, so I don't know how it would look. So we don't know how different they would look like, but we can see from the prices. So with the real conversion rate, we have prices that are like 17, 14, maybe this one is only 1, but prices that are at least a lot higher than those here, that we have 90 cents, 1, everything is lower than 2 euros. Okay. So it is.
Dania, I have one quick question here.
Yes.
So in both of these comparisons, I see that the predicted conversion rate is more or less the same for all products. And
Yes.
if you also look at the previous one where you sort by the actual conversion rate, I feel like the predicted conversion rate is pretty much constant. So
Yes.
what does that mean for the model? Does that mean the model has done really badly, or what does it mean essentially, and how could this be fixed possibly?
Yes, that's a good observation. Indeed, the predicted values are quite similar because we are working with a data set that has not a lot of different input values. So the thing is that when we look at the number of predicted values, it's basically that line, like the linear regression is a line, and most likely that line is almost a horizontal line, like a constant.
Yeah.
Probably changes very little, or the inclination of the line is not that big, like the angle. That's why the values are similar. And that can change more if we add more information as input, because we only have one dimension that we are sending as input, which is the price. So that's the only thing that we are modeling, let's say. It is more interesting to, or once we can make the products different between themselves, like for example, adding the brand as information, then the prediction or the conversion itself can vary more. just because we know
Right.
more about the products.
Okay. So mostly in this case, the model is just too naive.
Yes, exactly. It's just a baseline model, so we have something to start from. And
Mm-hmm.
again, this is the idea is that we can see really clearly here, because we also saw the correlation that was inverse, like even though small, but inverse. So we see really that the products that are cheaper, they are going to be on top, just because
Right.
their prediction, the conversion rate is higher.
Mm-hmm.
So we can see that. And this is interesting if you have, if you work for an e-commerce or some sort of platform where you have access to a catalog of products. Would be interesting to see at least the product name, so you can see how different it is. For example, maybe here at the top you would see first, I don't know, if we're talking about food, it would be maybe here you have a lot of fruits and vegetables, and maybe here you have some other things like very small, I don't know, herbs, and like maybe just some things to season, that are really small. So you could also see that this would be pretty much changing the user experience, because at the top of the page or the first page, they would see a very different catalog of products that they can buy from. Yes, so now it's really up to you. So this was the part that what I had to share with you, and you can try adding new features to the model, or you can even try different algorithms that are not just the linear regression, but any other kind of regression models, to see if you get something that could be potentially more interesting. So the other thing that I can share from the experience of working with this in companies is that a lot of the times it's not only the conversion rate that is interesting to model, because maybe the conversion, let's say, is not the best signal for the business. So maybe what they care more is the revenue, for example, or even the profit for the product. So the idea would be not to just use conversion, but some sort of combination between conversion and revenue, or conversion and profit. Also potentially consider other aspects of availability of the product. So there's a lot of things that you can play with, and yeah, this is the idea for the next, I don't know, half an hour or something. So I can support you if you have any questions when you're trying to go to the top. When you're trying to do this using this e-commerce event history data set.
Thank you so much. I think that gave a lot of insights and yeah, helps see the whole idea, the big picture.
Cool. Yes, that is my idea, to just try to motivate you to try it out, to see that it's not complicated to have a first list,
Mhm.
and what kind of things you can do when you combine also the catalog data and the transactional data, or even the browsing data. So there's a lot that when you merge that information, you can play with them.
Yeah. So this data set that you used, it's quite a baseline, simple data set. Do
Yes.
you have any suggestions of data set with more features or something that could be used for further
Yes.
experimentation, probably?
Yes, so I can recommend going to Kaggle and checking out the other data sets available there. If you search for retail or e-commerce, you should find a lot of things. And if you also look for like events, which is how I found this one, I think I was searching for e-commerce events,
Mhm.
but what is not so easy to find, I must say, is when you find the combination of the information of products and the events. So a lot of
Right,
the things I could find, they had a lot of information about the product itself, but you had no idea about the conversion or how to calculate conversion.
right. Yeah, and
But
I think also the events can vary a lot.
yes, But if you are interested in this, like what you could do, and I think that this would be my recommendation if you want to have, let's say, more complex data sets
Mm-hmm.
to challenge yourself. The idea would be to really, you can download from Kaggle a catalog of products. So you have a lot of information about the products, and you can generate random events. So you can
Okay.
generate like the impressions, and you can generate purchases. So this is also possible to do with a Python code. So you just
Right.
write your own function, you generate the events, and from that you can calculate conversion and execute the same workflow we just did.
Okay. So we do have one question in the chat about I'm not sure what the name of the user is because it's more of a username, but
Okay.
the question is how would you implement this in a Django based website?
Okay, so what I do is, or what I have done is that I only take care about the sorting, or not even the, let's say, the conversion in this case, or whatever is the target. This is not
Mhm.
shared, but we just share a JSON with this information of the products in the order that they should show. And then the consumer from the backend of the website or the app reads from that. So it's basically a queue that we serve.
Right. So the website would essentially collect the user data, use it as input for the model, and then output a queue. Right? I think that would
Yes.
be the end to end. Okay.
Yes, so it's kind of like you could also have some sort of API that is connected to this event data, and also
Mm-hmm.
puts together the catalog data, probably have it in some database, and just update the sorting order using the model, and that's
Right.
it. You have the list.
So for maybe for parameters of how to measure how much a product is used, there would be conversion rate, maybe click through rate, any other parameters that you think can be quite insightful, maybe?
Yes, so I think I even had this in the slide. Yes. Let me share here because this is part of what maybe the next step. So the target itself could be improved. So what I mentioned here, what else you can do is that the conversion rate might be an indicator, but maybe it's not the best indicator. So you can use a more company-oriented target. You can use other features about the customer, maybe even like add a step before to cluster customers. So you show different lists for different groups of customers. And I think that besides the actions that customers do while browsing the website, so you have the view or the add to cart, but you also have different things that people do, like how much time they spend in the page, if they like, if the page is big enough, let's say, if they roll down to see more product details or reviews, and this kind of thing can also be a signal that people are interested in your product. And other things are if you know that products are bought frequently. So, for example, food we have to buy almost every day. So those kind of repeated stuff, they maybe have a better conversion just because they are consumed more frequently. So that could also be transformed into input feature. Yeah.
Okay. Yeah, so probably using the product type or the shelf life or something like that as a feature.
Yes. Yes. And yeah, I mean, there's a lot of things to play around with. And I think what is most important is to have this understanding that in the end, to measure this, you really have to deploy it. You have to really put it in front of the users. And like in an A/B test setting, let it run with the people for real to see how good it is or how bad it is. Because the metric that we use it to measure the model performance is just a way to have an idea or an orientation if the model is good or not, but it's not going to tell you that now your users are going to love your e-commerce. No, so you really have to show it and see Like in the beginning when I showed that loop that you have the input and then you train and then you put it back. So this is really what happens all the time. You iterate on the solution.
Yeah, and I would also imagine there are more factors that come into play, for example, the UX and those kind of things.
Yes, for sure. Yeah, it's always a combination of the things that are moving for the user experience.
Right.
Yes,
So,
and I'm here now. If you would like to ask any other questions. Oh, yeah. This is the last slide, so thank you for being here in this hour to learn a bit about the product list. And if you want to try it out, then you can use that free data set from Kaggle. But maybe you want to try out different algorithms and use also different features.
indeed, yeah. I think the more you experiment, the more you learn about it.
Yes, you really have to play around with it.
And so here you talked about just a very simple algorithm, and from your experience, do you know any algorithms that perform better than others or are recommended in this kind of a scenario? Or is it just an experimentation?
Yes, so from the experience I have, I must say that this was never like my main project in the company. I was always supporting my colleagues working on this project and also being like the backup when they were not there on vacation or something. So I have some familiarity with this. And what happened a lot of the times is that changing the target was having a lot of impact, let's say, on the final product list. So just by understanding better what businesses want to see, like talking with the stakeholders and like showing them what was our proposed new PLS, but then
Mhm.
listening from them, like for example, if I show it like that, the one that we came up with that shows a lot of cheap products on top, they wouldn't like,
Yep.
because then people just go to the website and they think that we are only selling cheap stuff. And also it's
Right.
not going to be sustainable for the business itself. A company cannot only sell stuff for $1. So there's always this back and forth and trying to understand how to make it relevant. And a lot of the times,
Mhm.
or in the beginning, really, when you start with the e-commerce, you don't have any model or you don't have any data. So you just have a hunch what you want to show. And once the users start interacting and you start using those different targets that also optimize the business. So as I mentioned, one of the most popular ones was either profit or revenue.
Yeah.
But yeah, combining that in the conversion rate really helped push products that look better. They are not more expensive only, but also that they are real products that drive people to go to an e-commerce. Let's put it like this.
Right. So
Because, for
products you
example,
would like to
maybe
buy, maybe.
yeah, because for example, maybe you don't go to Zalando to buy socks. Maybe you go there to buy a new pair of boots. And then you
Right.
see that maybe I also need some socks. So I'm here already, I'm just going to buy it. But this is not what you
Mhm.
want to see front page. You want to see the new collection of boots or the
Right.
clothes, and then you end up buying some accessories. So that's usually how it
Indeed.
is. Yeah.
Yeah. So then we target the main products and accessorize essentially.
Yes, yes. Yeah, you can also see that from the brands or maybe from the product categories. So if you have categories like shoes and categories like accessories, then maybe this can also play a role. Yeah.
That's quite interesting indeed.
Yeah, there's a lot that you can do in this. That's why also it's good to have this approach to start simple and iterate on the solution, because otherwise you get lost with so many things that you want to do and you want to try out that you really have to organize it and start simple and build it up.
Right.
So I have a question. Well, so your say like what you delivered to the business was the list. So did they like look at the model or
Yes, so the idea is that we presented this before to stakeholders, like the process in the company was to present it and to have, let's say, a test page where they would see the product like if the new list was implemented. So it was like a beta page where they would see it. And if they wanted to have more information, like why is this product on top or not, then we had everything saved in our database. So we documented it in our own database. And if they wanted to see why or what was the reason and like really what were the scores, let's say for the ranking, then we would be able to provide it. But this was not usually what they were really interested in. What they were mostly interested in is why is this one on top when it was before on page 4, or why is the product that was once in second place now is in place, I don't know, 30, and they didn't want to lose, let's say, those products. So sometimes it was tricky to balance, the business needs and the results of the model. So I would say maybe a combination of both works well. Like you have the list that provides you the person with something that they can then, okay, maybe we should just put a rule on top of that, or like, consider some filters maybe. Yeah.
So I have one more question that just popped into my head. So, how do you account for maybe time based or seasonal variability? So, for example, in the summers, the sale of certain products would be much better, and I would imagine the same for winter. So, how would you incorporate this into your algorithm and into the
Yes.
product
So
list?
there is also when you go to the catalog of products, you have potentially this, especially if it's about fashion. You have if it's the collection of summer or collection of winter, this kind of things can be used. But in general, you don't know. So, for example, if you are talking about, I don't know, boots, yes, boots would be more for winter. So the entire category would be should be bumped down when it's summer. Yeah. So this kind of thing we can find out via this conversion, because probably either people don't see it, or if they see it, they don't buy so much that they would buy, for example, sandals. So this is something that is a natural response to what people are looking for and what people are buying. That's why this model needs to be constantly updated. And for example, you should take the number of impressions from the last week or 2 weeks, but not for the last 6 months, because otherwise it's not relevant. What people were doing 6 months ago is not relevant for tomorrow. So this is also something to play around with. Like this data set that we worked with, I think it was 5 months of data.
Mm-hmm.
And maybe it could be interesting also to play around with it and like slice it depending on the time frame to see how much it changes. If you consider first 2 months or the last 2 months of the data set.
Okay.
Yeah, and this is something that the colleague of mine that was working on this likes to say, is that big data is not always best. Like in this case, small data was better because it's just more relevant for what consumers are looking for in this period.
Indeed,
it
indeed.
is
Yeah.
smart data
Yeah,
which fits
exactly.
would be also interesting to find out how do you know the user or the your customer which products they have seen, but I guess you know it somehow. They know it somehow.
I
And
would
this,
imagine through the user ID you could relate to people. And
yeah, in this data set, they
Tracking
even
them.
had user
Cookies.
session. So it's the same session. Yeah,
Okay. Some cookies and
yeah, probably. Or when it's on the app, you have the installation ID. So that it's always from that same installation. And people could buy a new phone or reinstall the app, but usually that's enough.
interesting.
So we don't have any questions on the chat so far. So maybe we give it, I think we've given it long enough, so we could just conclude. And yeah, thank you
Yes, sure.
everyone for joining in. And thank you so much, Dânia, for the lovely and also the thought-provoking session about. So as a user now, I'm more aware of what goes into the backend, and maybe I can try to game it at some point. So it's quite interesting also as a data scientist. So thank you so much for the session, and have a wonderful evening to everyone who's watching, and see you at the next session. Good night. Bye.
Thank you. Thank you for having me. It was really cool to present with you guys.
Thank you. Have a nice evening.